Right, this time we're going to use the same mathematical technique, but we're not going to be able to just do it with a plus bn. We're actually going to need three terms in this equation. We're going to need a plus bn plus cn squared. And we're going to use the same method that we used last time. We're going to find the first lot of differences. If we take the difference between 3 and 1, we get 2. The difference between 6 and 3, we get 3. The difference between 6 and 10, we get 4. And the differences between 10 and 15, we get 5. So now we can see that our first row does not have the same number. We won't get zeros in the row underneath until we have the same numbers in the row above. So now we know to go to one new level, second lot of differences. The difference between 3 and 2 will be 1. Between 4 and 3 will be 1. Between 4 and 5 will be 1. So we now have the same number on the second row. That tells us that as soon as we get down to our third row, the third row of differences, we are finally going to get the 0 that we want. Okay? And when we start getting these zeros, that tells us then that we know that we are going to have an equation of the form a plus b times n plus c n squared. We had three differences. We're going to have three constants, and every time we increase the power of n by 1. Okay? Here we have n to the 0. Anything to the power of 0 is actually 1. Here we have n to the power 1, our second term here. And then the next time we have n to the power 2, and then we would have continued. But we can finish now with this expression. So we don't need these help lines anymore, so we take them away. Because now we have some equations to solve, and we're going to need quite a lot of space to solve these equations. Because now we're going to have three equations. We've got three equations and three unknowns. Okay, where do we get these equations from then? Well, we get the equations the same way that we did last time. We start with what happens when n equals 1 to this equation. Well, we would have the form a plus b times n. We know that n equals 1, so we'd have b times 1 plus c times n squared. We know that n is 1, so the answer is going to be c times 1 squared. And what is all of that going to equal? It's going to equal the answer that we got in number of blocks when n equaled 1. So that is going to equal 1. So here's our first equation that we can rearrange. A plus b plus c equals 1. This is equation number 1. Right. To get equation number 2, we put n equals 2 into our equation. This is our standard equation, a plus bn plus cn squared. We put n equals 2 into that. Okay, a, there's no n there, so that stays the same. Plus b times n. Well, n equals 2, so it will be b times 2. Plus c times n squared. N equals 2, so it's going to be c times 2 squared. And what is all of this equation going to equal? It's going to equal the answer that we got when n equaled 2 from our table. So that is going to equal 3. So let's rearrange this equation. We will get a plus 2b plus 4c squared equals 3. This we will call equation 2. How do we get equation 3 then? Well, we put n equals 3 into the same equation. We know that when n equals 3, we still have the standard form of the equation here, a plus bn plus cn squared. But now n equals 3. So we have a, there's no n's to multiply in there, so that stays the same. Plus b times n, well, n equals 3, so that's going to be b times 3. Plus c times n squared, n is 3, so n squared will be 3 squared, which will be 9. Wendy? Sorry, you guys are correct. Going back here, whoops, this is the wrong term. So, when we work out 2 squared times c, the answer will be 2 squared is 4 lots of c. So the answer to equation 2 would be a plus 2b plus 4c equals 3. Now we're working out for n equals 3. We get a plus b times 3 plus c times 9 equals, and what does it equal? We look at what the answer when n equals 3 to the number of blocks was. The number of blocks was 6. So the answer to our equation here is going to be 6. Let's rearrange that so it's a little bit more sensible. That gives us a plus 3b plus 9c equals 6. And this is our equation number 3. Now, in maths, if you have 3 equations and 3 letters that you don't know the answer to, you can solve it by substituting. And it was the same as we did when we had 2 equations. We rearranged so we got first a by itself. So we'll do that here. We rearrange equation 1 so that a equals, and when we move b and c over to the other side. So b on this side becomes minus b on the other, and c on this side becomes minus c on the other. So we get our first equation rearranged. We now know that a equals 1 minus b minus c. Now whenever we can see a in equation 2, we can actually put this new term in, 1 minus b minus c. And we do that here. So wherever we see a, we write 1 minus b minus c plus 2b plus 4c equals 3. And we've just substituted the value we got from equation 1. Now we've got loads of b's and c's and we have to sort of add them all up. Add up all our b terms, add up all our c terms. When we do that, so it's just rearranging this equation, we get 1, we get minus b plus 2b, that would give us plus 1b, and we get plus 4c minus a c, that would give us 3c, equals 3. Now we need to rearrange that so that we get b by itself. I want the answer b equals. So what happens? The 1 goes over to the other side and becomes 3 minus 1. Plus 1 on one side becomes minus 1 on the other. The 3c goes over to the other side and becomes minus 3c. So I now know that b equals 2, 3 minus 1 is 2, minus 3c. So here is my answer for b. b equals 2 minus 3c. Now I have an answer for a and I have an answer for b. And I put both of those answers into my third equation. Okay? So now it looks like there's going to be lots of letters here. Whenever I see a, I write 1 minus b minus c. Wherever I see b, I should write it equals 2 minus 3c. But we'll change that later so I don't confuse you too much. Plus 3b, which instead of writing b, what should I write? I should write that b equals plus 3 times b, but I know that b equals 2 minus 3c. So I replace my b with 2 minus 3c, and then I add, keep everything else the same. So what we're doing here is we're working out what a and b are, and then we're just substituting. Now I've got an equation with only b's and c's in, so I actually need to do something with this minus b as well. I need to put that b equals 2 minus 3c. So I need to rewrite this equation, and I'm desperately running out of space here. Let's see if we can squeeze it in down here. So I would get 1 minus b, which I know is 2 minus 3c, minus c, and let's expand these brackets. 3 times 2 is 6. 3 times minus 3c will be minus 9c, plus 9c equals 6. Now we've got some simplification to do, which we should be able to squeeze up here if I write really small and change color of pen. So 1 minus 2 minus times minus 3c will give us plus 3c, minus another c, plus 6, minus 9c plus 9c. Actually, those two cancel out and just turn into 0. So we can put the equal sign in here directly. Equals 6. Right, let's get our numbers together and our c's together. What we have is we have 3c minus 1c, which will give us 2 lots of c. And then if we get all our numbers together, we've got 6 plus 1 is 7, minus 2 is 5. So we get 2c plus 5 equals 6. So now we can rearrange this equation to get what 1c is. Well, we know that 2c is going to be 6 minus 5, which is going to be 1. So if 2 lots of c is 1, c is going to be 1/2. So now we have an answer for c. As soon as we get an answer for c, we know that c equals 1/2. We can put it back into this equation. We know that b, let's take a new color here. We know that b has to equal 2 minus 3c. But we know that c is 1/2, so we know that b is going to be 2 minus 3 times 1/2. 3 times 1/2 is 1.5, which is going to give us that b also equals 1/2. So now that we know that b equals 1/2, and we know that c equals 1/2, so we put this back into equation 1. We go back up here to equation 1. We know that a equals 1 minus b, but we know that b is 1/2 now. Minus c, which is also 1/2. So we're going to get that a is 1 minus 1/2 minus another 1/2. It's going to be 0. So now we know that a is 0. So our equation to this, looking very complicated, is actually really simple. It means that a is 0. And our equation is going to be 1/2 of n plus 1/2 of n squared, which is really the same as n plus n squared all divided by 2. So I am saying I've proved mathematically now that our equation here is going to be n plus n squared divided by 2. Let's try it then. Here's n. N is 1. Plus 1 squared is 2. 1 plus 1 is 2. Divided by 2 is 1. 2 plus 2 squared. 2 plus 4 is 6. 6 divided by 3 is 3. 3 plus 3 squared. 3 plus 9 is 12. 12 divided by 2 is 6. 4 plus 4 squared, that would be 4 plus 16, which is 20. 20 divided by 2 is 10. So we've actually solved mathematically our formula and proved that this sequence has the equation n plus n squared divided by 2.